Hello everyone, today we are going to integrate this expression here by means of substitution. And we are going to substitute x equals to tangent theta into this indefinite integral. So there's something special about indefinite integral, so do stick around to the end of this video so that I can share with you how to approach integrating such expressions. Now the very first thing that you can do when you see that this is a substitution question for an indefinite integral is to differentiate x equals to tangent theta with respect to theta. Now, doing so, we will have dx over d theta equals to secant squared theta, and this implies that dx is equals to secant squared theta d theta. Now, this expression will be very useful in the subsequent steps. Now, coming back to this question, we will start to integrate x squared over 1 plus x squared dx. Replacing all the x with tangent theta, we will have tangent squared theta over 1 plus tangent squared theta squared. And dx will be replaced with secant squared theta d theta. So this is where it comes in handy. And this will be equals to tangent squared theta over secant squared theta. Because 1 plus tangent squared theta is secant squared theta, we have basically cancelled out the denominator. Subsequently, we will have sine squared theta over cosine squared theta, which is a tangent squared theta, multiplied by the reciprocal of secant squared theta, which is cosine squared theta over 1. Now I've decided to change all of them into sine and cosine so that I can simplify the expression better. This will give us sine squared theta. Now remember, if we integrate a trigo ratio with an even power, we will need to use the cosine double angle formula. So which formula to use? We will use the one that involves sine squared theta. So this is 1 minus 2 sine squared theta, and making sine squared theta the subject, we will have half multiplied by 1 minus cosine 2 theta. So bringing it back to our question, we will then have half integrate 1 minus cosine 2 theta with respect to theta. We will subsequently have half theta minus sine 2 theta over 2 plus c, where c is an arbitrary constant. Now don't just stop here. Many students make the mistake of ending the question over here, but we need to change all the theta into x as required by the question. Now in order to obtain x from sine 2 theta, we first need to find the trigo ratio that involves sine theta and cosine theta. And this comes from x equals to tangent theta. Now drawing a quick triangle over here, if x is equals to tangent theta, it means that the adjacent is 1 and the opposite is x. Therefore, the hypotenuse is square root 1 plus x squared. So referring from this diagram over here, sine theta is equals to x over square root 1 plus x squared, while cosine theta is equals to 1 over square root 1 plus x squared. Now these are the two vital ingredients that are required for the subsequent step. So integrating x squared over 1 plus x squared squared is equals to half theta minus 2 sine theta cosine theta. Now this is the double angle formula of sine 2 theta divided by 2 plus c. Now you realize over here that we can use the values of sine theta and cosine theta to substitute into this expression. So doing so, we will have half tangent inverse x minus 2 x over 1 plus x squared, 1 over square root 1 plus x squared over 2 plus c. Simplifying further, we will then have half tangent inverse x minus x over 1 plus x squared plus c. And this is what you see in the question over here. So don't forget to put the word shown to finish off this question. Now I do hope you have learned something from this video. This is a very important question to train and practice your trigo foundational skills. And if you have any questions or comments, do leave them down in the comments box below. Thank you so much for watching.